I want you to think about the last time your power went out. Maybe it was a storm, maybe it was a grid failure, maybe it lasted 3 hours, maybe it lasted 3 days. And in that window, everything that runs your life, your refrigerator, your lights, your phone, your water pump, all of it went silent. And there was nothing you could do except wait for the utility company to fix a problem you had zero control over. Now I want you to think about this. A metal cylinder the size of a shoebox sitting next to a small fire made from wood scraps off your property, sticks, bark, offcuts from a project, fallen branches quietly spinning a generator. No gasoline, no propane tank to run out of, no fuel delivery to schedule, no engine oil to change, no carburetor to clean, just heat on one end, a temperature difference, and mechanical motion that keeps going as long as the fire does. That's a Stirling engine, and it is one of the most suppressed, most misunderstood, most underestimated pieces of technology sitting outside mainstream energy conversation right now. Not because it doesn't work, it works extraordinarily well for the right applications, but because there is no fuel to sell you, no filter subscription, no annual service contract, no proprietary parts that wear out on a schedule designed to keep you paying. A Stirling engine running on wood you gathered for free from your own land is an energy source the entire fossil fuel supply chain makes exactly $0 from. And that is a problem for a lot of very large, very profitable companies. It is not a problem for you. Before I get into exactly how this works and what it can realistically power, hit that like button and subscribe to Lost Tech Vault right now. This channel exists to surface technology that works, that's been proven, that's been quietly sidelined because there's no recurring revenue in it for the industry. Every video connects to the last one. Subscribe and turn on notifications so you get every piece of this puzzle as it comes out. Here's the thing about Stirling engines that most people get wrong immediately. They hear engine and they think internal combustion, pistons firing, fuel igniting, controlled explosions driving mechanical force. They assume a Stirling engine works the same way with different fuel. It doesn't. The operating principle is completely different. And understanding that difference is what makes you realize why this technology is so remarkable. A Stirling engine runs on a temperature difference. Not combustion, not explosion, a difference in temperature between two ends of a sealed cylinder. Here's the actual physics. Inside the engine is a fixed amount of gas, usually air or helium, sealed permanently. No intake, no exhaust, no fuel mixing. The gas never leaves the cylinder. What happens is this: one end of the engine is heated, the other end is kept cool. The gas inside expands when it moves toward the hot end and contracts when it moves toward the cool end. This expansion and contraction drives pistons in a continuous cycle. The pistons turn a crankshaft. The crankshaft spins a generator. You get electricity. The heat source doesn't matter to the engine. It doesn't care whether the heat comes from burning wood, a propane flame, a focused solar array, geothermal heat, industrial waste heat, or a candle. Any sustained heat differential drives the cycle. The engine is completely agnostic about where the heat comes from. This is why Robert Stirling patented this design in 1816, and why engineers have quietly respected it for 2 centuries. It is the most fuel-flexible engine ever designed. And paired with the most abundant, renewable, genuinely free fuel most rural and suburban properties have, wood, it becomes something close to an indefinite off-grid power source. Let's talk about what it can realistically power, because I would rather be honest with you than oversell this and have you disappointed. A small Stirling engine running on a modest wood fire, we are talking a fire roughly the size of what you would build in a backyard fire pit, generates between 100 and 500 watts of continuous electrical output, depending on the engine size, the quality of the heat differential, and the efficiency of the generator it is coupled to. Purpose-built hobby and small commercial Stirling generators in the 200 to 500 watt range are available from manufacturers in Germany, Japan, and increasingly from small American fabricators, typically running $300 to $800 for a complete unit. What does 200 to 500 watts power continuously? LED lighting for your entire home, phone and device charging, a chest freezer, a well pump in short cycles, a radio and communication equipment, a fan, basic power tools in rotation. What it does not power: central air conditioning, electric ranges, electric water heaters, or anything with a large resistive heating element. Stirling engines at this scale are not whole home replacements for grid power. They are serious, reliable off-grid supplements. And in a grid-down scenario, a 300-watt continuous source running off wood scraps is the difference between genuine resilience and total dependence. Pair a Stirling generator with a modest battery bank and a charge controller, and the math gets more interesting. Run the engine for 6 hours while you have a fire going. Store that energy. Draw from the battery bank the rest of the day. A 300-watt engine running 6 hours produces 1.8 kilowatt-hours. That's enough stored energy to run lights, a chest freezer, and device charging for 18 to 20 hours. Repeat daily and you have a wood-powered off-grid electrical system with no fuel cost ever. Now here's what makes the wood fuel side of this genuinely remarkable. The wood consumption for a Stirling engine fire is dramatically lower than you would expect. Because you are not trying to generate violent heat for combustion, you are maintaining a sustained, moderate heat differential. A well-managed Stirling fire runs efficiently on small-diameter wood, branches under 3 inches, scrap lumber offcuts, bark, dense woody debris. The kind of material that accumulates on any rural property constantly, that most people burn in a fire pit anyway or chip into mulch, or simply leave to decompose. 1 acre of managed woodland in most temperate regions produces more than enough sustainable woody debris annually to run a small Stirling generator 6 hours a day indefinitely. Without cutting a single living tree, without purchasing a single piece of fuel, the land produces it, you collect it, the engine converts it. This is not theoretical. Small-scale biomass Stirling generation is actively used in remote communities in Scandinavia, in off-grid homesteads across the American Southwest and Pacific Northwest, and in developing world applications where fuel supply chains simply don't exist. The technology is proven. The fuel source is proven. The gap is awareness. The maintenance picture is the final piece, and it's genuinely different from any combustion engine you've dealt with. No spark plugs, no fuel filters, no carburetor jets, no oil changes on a combustion cycle. The moving parts in a Stirling engine operate at low speeds under low mechanical stress. Bearings need periodic lubrication. The heat exchanger needs cleaning. That is the maintenance list. A well-built Stirling engine running on clean wood fuel has a realistic service life measured in decades. Compare that to a gasoline generator. Carburetor problems within 2 years. Fuel degradation if you store gasoline. Oil changes every 50 hours. Parts that become unavailable for older models. An ongoing cost relationship with a fuel supply chain that can fail you exactly when you need it most. The Stirling engine asks for wood and returns electricity. The wood grows back. Subscribe to Lost Tech Vault. Next week, I am covering how to pair a small Stirling generator with a salvaged battery bank to build a complete off-grid power system for under $500 total. Everything connects. You are going to want that one. See you next week.